Graph the function y is x cubed minus 9x squared plus 15x plus 10 using the calculator to find the important features. So, let's just get rid of that one. And we need to change our function. We've got x cubed minus 9x squared, add 15x, add 10. Let's graph that. We need to change the axes a bit to get a good picture. So let's go from -4, let's say, to 10, and we take that -20 and maybe make that 30. And we do get all the important features on. So let's see if we can find the roots to start with. So we've got one here at negative 0. Just a bit more than 0.5. So let's mark that on here, and then find the next one. So that one's just a bit more than 3. Obviously it's a sketch, we don't need to make sure that this is accurate in any way. And then the next one's just past 6. So that's here. And let's find the turning points. So we've got a maximum turning point here, and that happens at 1. And then we've got a minimum turning point, and that happens at 5. So we can make a sketch of that. So we know there's a turning point just here, comes back down through this 0, turning point here, and then like so. So that's our sketch of y is x cubed minus 9x squared, add 15x, add 10. We want to use the information we've gained from the first two examples to sketch the derivative function on the same axes, and then we can use the calculator to check our solution. So we know that the gradient function will cross the x-axis, i.e. indicating the gradient is 0 at the turning points. Now along this section here, the gradient of our function is positive, it's sloping upwards. That means the gradient function must be above the axis. So it's very steep down here, and it becomes less steep, so it must be coming down towards this 0 like so. In between here and here, we can see the gradient is negative, and it will take its steepest point somewhere in the middle here. So it's very shallow near the turning point, shallow near this one, and it'd be steeper somewhere in between. So it's going to move away from the x-axis and then back towards 0 like so. Then from here it's going to get steeper and steeper, and it's positive, so this must be back above the axis, and because we get steeper it moves further away from the axis, indicating a greater positive value for the gradient. So let's see what we've got with the calculator. So if I just copy this and paste it into here, and then we graph both of them, and you can see this is actually a perfect quadratic. Mine's not that good, but it does indicate the major features.